In this section, we're going to be writing equations. First, we'll start by translating a few expressions into equations. Then we'll look at a few word problems, translating word problems into equations. Before we start, I want to point out the most important thing when we're translating either expressions or word problems into equations is looking out for keywords. And we want to identify many of these keywords as we go along. So let's get started. Our first one is we're going to say a number plus 8 is 15. Okay, so let's point out a few keywords here. The first one is a number. A number can be any old number, so why don't we just define that as x? We're going to let x be a number. Okay? The next one is plus. Well, we know what plus is. Plus is just a plus sign. So we're a number plus 8. So x plus 8 is 15. Is means equals. So a number x plus 8 equals is 15. Okay? So this is our equation for this expression here. Let's look at another one. Let's say we have 7 less than 7 less than twice a number is 21. Okay, we got some keywords here to identify. 7 less than. Less than means subtraction. So the quantity that we're looking for, we're going to subtract 7 from. So we're going to have a minus 7, and there's going to be a quantity over here. So 7 less than something is we're subtracting 7 from something. And what are we subtracting from? We're subtracting from twice a number. Okay, twice a number just simply means if we let x be a number, well, 2 times a number, or 2x. So 2x is twice a number. 7 less than twice a number is 2x minus 7. And then again, we have is, which means equals. So 2x minus 7 equals 21. 7 less than twice a number equals 21. Let's look at a few more of these. The next one we have 4 more than, say, 3 times a number is 16. Okay, 4 more than 3 times a number is 16. Let's pick out a few keywords. Well, up here we saw less than. Right here we have more than. So what do you think more than means? Oh, you got it right. That means we're going to be adding 4. So we're going to be adding 4 to some quantity. 4 more than something means add 4 to it. Next we have 3 times a number. We saw up here that if we call x, or any variable, a number, x equals just any number, 3 times a number is 3x, 3 times x. And then we see is again, which means equals 16. So 4 more than 3 times a number is 16. It can be translated into 3x plus 4 equals 16. Okay, let's do another one of these. Let's do an application. Let's say $30 is half of, let's say, of the money spent, half the money spent on tickets. Okay, so let's say we're going to a ball game or a concert or what have you, and $30 is half the money spent on tickets. Okay, well, we can start out with 30. 30 is, so that means equals. We have is, so 30 is. It's the same thing up here, just in reverse. Then we have half of the money spent on tickets. Well, if we let x be the amount of money spent on tickets, the money spent on tickets, we're going to call x. Well, half of the money spent on tickets is half of x. So 1/2 x equals 30. $30 is half of the money spent on tickets, and we're defining the money spent on tickets as X. Okay, so these are a few expressions that we can use keywords. We can pull out the keywords, and we can actually turn into an equation. Okay, now let's do a couple word problems. Let's run through a couple word problems and translate them into equations. Let's say Paul has a painting service. Paul charges $20 per job. We have $20 per job. And he charges 50 cents per square foot. And let's say Paul earns $30 for a job. Okay, we want to write an equation for this. The 50 cents is per square foot. So the amount of money he earns is going to be dependent on how many square feet the job is. All right, so let's begin. Let's say $20 per job. Let's say he earns, let's start with this. We have $30 total. So we know that the equation that we're about to write is going to equal 30. He earns $30 for a job. Okay, so how do we get that $30? Well, the job has an automatic fee of $20. So it's going to be something plus 20. This is 20. And then he's charging 50 cents per square foot. Let's let X equal the square footage. Square foot. So 50 cents for each square foot is going to be 0.50 actually, but we can just say 0.5 X. So for each X, each square foot, he's charging 50 cents plus a $20 flat fee for a job, and he makes $30 total. We can actually go ahead and solve this for X and see exactly how many square feet that the job was for him to earn $30, but we'll leave that for another video. Right now we're just translating. But you can see the usefulness for equations. Let's look at another one. Let's say renting a reception room for a wedding costs $500. We're renting a reception room for a wedding. And let's say it costs an additional $2 per person. So for each person you have at the wedding, for the reception is another $2. So we have $500 and then $2 a person. The rental cost a total of $1,000. $1,000 total. Okay. Let's go ahead and define our variable. Let's say X is the number of people. X equals the number, number of people. Number of people. Okay. So let's start with our $1,000. $1,000 is going to be the total here. So whatever our equation is going to add up to $1,000. Now we have a flat rate of $500 that's going to comprise part of that $1,000. So we're going to have $500. The other half is going to be $2 for each number for the amount of people. So it's going to be 2 times X, or $2 for each person that arrives at the reception. So 2X plus 500 is going to equal 1,000. And again, if you're planning a wedding, you can use an equation just like this to see how much it's going to cost you, or how many people you're going to have. Very useful stuff. Let's do a couple more. Let's say we're renting a van. Renting a van costs $45 a day. $45 per day. And let's say the rental company charges an additional 15 cents per mile. 15 cents per mile. Okay, the cost of the rental is $115. So we have a total cost of $115. Well, let's say we want to write an equation and see how many miles that we drove. Well, we know the total is going to be 115. So whatever our equation is going to equal 115. Now, let's say that we just, I guess we're just renting it for a day. $45 is the flat rate. So whatever we're adding, whatever the cost of the $115 is comprised of, half of it is $45, or one part of it is $45. The other part is 15 cents per mile. Well, if we let X equal the number of miles, we're just defining our variable X, 0.15 times X is going to give us 15 cents per mile. So 0.15x plus 45 equals $115. So we're renting a van for the day. Okay, we're running out of time. Let's do one more. Let's say Peter gave Paul 3 more toys than he already had. Paul already had 6 toys. Okay, so let's go ahead and write a quick equation here. Let's let T equal the total number of toys. Total number of toys for Paul. Okay, well, T is going to equal, let's see, well, Paul already had 6 toys, so he has 6, and Peter gave him 3 more toys. So it's going to be T equals 6 plus 3. And we can go ahead and say that that's 9. That was a very simple example, but it just shows you that the power of being able to translate an expression or a word problem into an equation. Because basically the main thing of algebra, the usefulness of it is if we write an equation here, it'll save us a lot of time because we actually don't have to rewrite something every single time. We can just plug in, let's see, for example, the number of people at a reception for a wedding. We can just plug in a number of people coming to the reception to see what our total cost is. Instead of having to rewrite an equation every single time, we can just plug in for a variable. Equations are very useful, especially in the real world. I'm out of time. Make sure you go over this again and get familiar with translating expressions and word problems into equations, and I'll see you soon.